The last two all mixed up, so figuring out X, Y, and Z. And again, you got to look at the picture that's given to you. So I've got the two triangles. I've got the 45, 45, 90, and I have the 30, 60, 90. So I'm going to start with my 45, 45, 90, mainly because it's usually the easier one, but I'm actually going to have to start with that one because I only know the one side length, the 6 in that one. So I'm going to start by writing down my ratios, 45, 45, 90. Then my ratio of my sides, x, x, x times the square root of 2. So the segment I know about is the one opposite of the 90. So x times the square root of 2 equals 6. So then we're going to divide both sides by the square root of 2. So x equals 6 over the square root of 2. And we are not allowed to have a radical in the denominator, so we've got to rationalize it. So we're going to multiply the top and the bottom, square root of 2 over the square root of 2. So then x is now 6 times the square root of 2 divided by 2. 6 divided by 2 is 3. So x is 3 times the square root of 2. So the length of these two segments here are equal to each other. So this x, the one that we were talking about, is 3 times the square root of 2. Now that we know what that segment is in the 30, 60, 90, now we're going to use our 30, 60, 90 ratios to figure out what y and z are. So 30, 60, 90, write down the ratio of the sides, x times the square root of 3, and 2x. And so the side that I know about is my 90 degree. So it is 3 times the square root of 2. So now I'm going to set up my equation. 2x equals 3 times the square root of 2. Now please don't get confused. I know that I'm talking about several different x's here. But remember the x, whenever I'm using this x, refers to the ratio length. So now I'm going to divide both sides by 2. And so I don't have to rationalize the denominator here. X is equal to 3 times the square root of 2 over 2. But I'm going to take this value, 3 times the square root of 2 over 2, and I'm going to times it by the square root of 3, and I'm going to set that up as a fraction. And so because I have the square root of 2 times the square root of 3, I can put them under the same radical, and I now have 3 times the square root of 2 times 3 is 6 over 2. So now for my 60-degree angle, 3 times the square root of 6 over 2. And so now let's figure out what goes where. So opposite of the 30 is the y, and y is now 3 times the square root of 2 over 2. Opposite of the 60 was the z, and that's going to be 3 times the square root of 6 over 2. All right, a lot of work. We got one more to go. So in number 20, it says find the missing side lengths of the hexagon and then find the perimeter. So we got a lot in this picture. We have the missing side lengths of the hexagon, R, S, T, U, V, W. So all of those outside edges. Well, in this picture, again, remember you're never allowed to assume anything. So if I look right here, in this picture, I have my right angle and my 45-degree angle, so I know that these two sides are congruent. So WV is going to be equal to UV. Okay? Well, also, again, I'm really not assuming anything. Since I have 3 right angles, that means that this segment also has to be perpendicular. So looks like I have a rectangle in this picture. So if this segment is 6, then this segment length has to be 6. And so if this one's 8, then this one has to be 8. So that's important because that's going to help me find what is WV and what is UV. So 45, 45, 90, x times the square root of 2. And so the side length I know about is the 90, which is 8. So 8 is equal to x times the square root of 2. And divide both sides by the square root of 2. So then rationalize the denominator. So I'm going to have 8 times the square root of 2 over 2. Okay, I've done it enough now. I'm skipping that step. 8 divided by 2 is 4. So reduce it down. So 4 times the square root of 2 is equal to x. And so that is going to be the length of UV and WV. All right, so we're getting there. So in the next triangle, so I have this 30-degree angle here. This is going to be my right angle because if this is a segment and that's 90 degrees, then this has to be 90 degrees. So 30, 60, 90, x times the square root of 3, 2x, and the length I know about, x is 6, so that means my 60 degree has to be 6 times the square root of 3, and my 90 degree is double the 6, so it is 12. So I'm looking, and I'm pretty sure I have all of my missing sides. So now to find my perimeter, so I'm going to use a different highlighter, and I'm going to go around and highlight. So 12 plus 8 plus 6 plus 4 times the square root of 2 plus 4 times the square root of 2 plus 6 times the square root of 3 are my outside edges. 12, 8, 6, 4 times the square root of 2, 4 times the square root of 2, 6 times the square root of 3 are my outside edges. And so when I add them all together, 12 plus 8 plus 6 is 26. 4 times the square root of 2 plus 4 times the square root of 2. It's like combining like terms. Because they've got the same identical radicals, I can put 4 plus 4 together, and I get 8 times the square root of 2. And then plus 6 times the square root of 3. And so that is my perimeter.